Hello students, today we're going to be looking at transformations. Specifically, we're going to be talking about translations. Don't forget to take notes as you go and do the check that follows the video. So before we get into translations, we want to talk about transformations. A transformation of a geometric figure is a change in your position, shape, or size of that figure. So we can either slide it around, or it can get bigger or smaller, so on and so forth. So there are two things associated with this. The first would be your pre-image. That is your original figure that you're working with, and the vertices are noted such as A, B, C, D, so on and so forth. Then we'll perform a transformation, and we will get something called the image, and that is our resulting figure. And as you can see, our notation changes, and now that becomes A prime, C prime, so on and so forth. Now, some of our transformations are called isometries. And this is when we perform our transformation and everything about the pre-image and your image are exactly congruent. So let's take a look and determine if we have ourselves isometries. So in this first one here, the one on the left with the two hearts, if we were to take this image and we were to reflect it, what would you would see that you have the exact same thing. So this is considered an isometry. With the triangles in the middle, if I were to slide it and reflect it, again, I have myself an isometry because they're exactly the same size, same shape. But the ones on the right there, the two rectangles, they do not have the same size on any of their lengths. Even if their angles might be congruent, you can see that the length here and the length here are not the same. So in order to be congruent, they have to have equal lengths, and this is the case where it's not. So this is not an isometry. Now you have to be able to name corresponding parts, and we do that by using prime notation. So as you can see in our pre-image, we have the A, B, C, D, E, and F, and our image uses A prime, B prime, C prime, D prime, so on and so forth. So same letters means they correspond with each other. So for example, the image of C, angle C, would be angle C prime. Or the corresponding side of segment AB would be segment A prime, B prime. So we use the same letters to identify our pre-image and our image. Now, let's get into translation specifically. Now, translation is a transformation that maps all the points of a figure the same distance in the same direction. So it's essentially also known as a glide. Okay, we're going to be sliding something around in order to get it to be it from the image to our pre-image. And what we do is we use arrow notation for our translations. So what we'll have here is a rule such as this. So this is x comma y. This represents any point that we can possibly use. Then we have our arrow notation, and then this would be our designated rule for this example. So the x plus 4, what that means is we're going to be adding 4 units to every x in the points of your pre-image, and the y minus 2 means we're going to be subtracting 2 units from every y in the points of the pre-image. So we can also associate this with a shift to left, right, up, or down. So a plus would mean we're shifting to the right for our x plus 4, and the minus and y minus 2 means we're going to be shifting down 2. So now let's take a look at an example. If we have the figures for A, B, C, and D are given to us, what we want to do is find the image after our translation given our rule here. So as you can see, all the x values are going to be adding 3, and all our y values are going to be subtracting 1. So what I'm going to do first is I'm actually going to find my A prime, B prime, C prime, and D prime, and then I'm going to sketch both of them onto a piece of graph paper. So keep in mind we're doing x plus 3 and y minus 1 to each of them. So if we take a look at what A is negative 1, 2. So if I add 3 to negative 1, I will get 2. And if I subtract 1 from 2, I will get 1. So our image of A is going to be at 2, 1. Repeating this process for B, when I add 3 to the x coordinate and subtract 1 to the y coordinate, I get 2, 4. Similarly with C, when I add 3 and subtract 1, I get 7, 5. And then doing the same thing for D, I get 7, 1. So once again, I took all these x coordinates and added 3, and then all of these y coordinates and subtracted 1. So what I'm going to do is I'm going to graph both of these guys here onto a piece of graph paper, and making sure you connect the appropriate points. All A, B, C, D get connected, A prime, B prime, C prime, and D prime get connected. And our image and our pre-image look like this. Okay, so we can also look at the opposite where we determine the rule. So if I gave you the pre-image, such as this one right here, and I gave you L prime, M prime, and N prime, those are the points of the image, we can find a rule to describe our translation. Now since everything should move the exact same way At the exact same time, we really only need to look at one of the points. So I'm going to take a look at L. Now the preimage is at -6, -1, while L prime is 1, -2. So either identifying from a number line or doing subtraction like we did to find distance when it was a segment, we're always going to have to remember to do our image and subtract off our preimage. So for example, to get our x coordinate, or our horizontal change, if we do our image, subtract off our preimage, we get 7. Or you can think we're going from -6 to a +1, we're increasing by 7, so our rule would be x plus 7. Now keep in mind, since this is positive, that's why this became a plus. If this was negative, then this would be a minus. So let's take a look at our vertical change, or the change in our y's. So same deal, if I were to do the image minus the preimage, I would get -1. Or, looking on a number line, to go from -1 to -2, we're decreasing by 1. So our rule for our y coordinates are y minus 1. Putting those together as a rule and arrow notation, we will have xy followed by our arrow, and then x plus 7 and y minus 1. And this would be our translation rule. We also can have a composition of transformations, and this is when we have a combination of 2 or more transformations, and each transformation we do is done to the image of your preceding transformation. So as you can see from here, if our ball can move directly from player 3 to player 5 by a direct pass, that would be one translation in itself. However, we can also do a composition of them. The ball can be passed from player 3 to player 9, and then player 9 to player 5. So as you can see, composition of any 2 translations is essentially another translation. Now that is only really applied to when we're talking about 2 translations, not necessarily any of the other ones we talk about. So just to do an example with this, we're going to use this bishop right here, and essentially we're going to use 0, 0 to represent the bishop's original position, and we can then see the new position, which is right here. We're going to write the translation rule for each of those movements there. So for our first movement, it moves 4 squares to the right and then 4 squares down. So that one would be represented by x plus 4 and y minus 4. Then doing the same thing for our second one, it would be x plus 2 and y plus 2, since it moves 2 to the right and 2 squares up. So our composition will look like this, where we'd have one followed by the other. We can also represent this as one single translation. If we put them together, we can see that essentially the x is going to the right 6 units, but if we were to combine these together, it's only going down 2 units, and this would be the single relationship from the original position to the new position. If you have any questions, please make sure you write them down now and bring them to class tomorrow. Also, do not forget to do the completion form found after our video. I'll see you tomorrow.